Have we done exponential rules level 3? We stopped at 2. Okay. Let me. That's back one from this. We'll do that real quick, and then we'll come back to this. Okay, exponential rules. Okay, 4d to the negative 4th, and then v to the negative 8 over 3d to the 4th in parentheses to the 3rd. And you might remember on the bottom, when we've got all that stuff in parentheses and then the 3rd on the outside, every exponent on the inside, so I'm gonna go ahead and write the exponent on the 3. You're gonna multiply each exponent by 3, so that 1 times 3, so it'll end up being 3 to the 3rd on the bottom, and then d to the 12th on the bottom, multiplying all those exponents. So I'm just gonna do that one step just to start with, not doing anything with the top. On the bottom, doing the exponents, multiplying 1 times 3, and then 4 times 3. We've got 3 to the 3rd, d to the 12th. And there's a few different ways you could deal with the negative exponents. I'm just gonna, since we've got d's on top and on bottom, highlight that. If you've got d's on top and on bottom, you can just subtract. So I'm gonna do that up top, d to the negative 4 minus whatever exponent's on the bottom, so 12, and then v to the negative 8. And then on bottom, so that deals with the d that's on bottom. All we've got down there now is the 3 to the 3rd, which is 27, 3 times 3 times 3. Negative 4 minus 12 is negative 16, and v to the negative 8. So all I did there was put the negative 4 and the negative 12 together. Okay, so we've done this subtraction with the d's, and that always takes place on top, by the way. The subtraction takes place on top. But any negative exponents that we end up with, so this negative 16, this v to the negative 8. What's the exponent on the 4? 1. Positive exponents stay where they are, but negative exponents, as long as you've done the subtraction, negative exponents are going to move through the fraction line. So make exponent positive. You guys would have had this in your notes from the other levels, level 2. Make exponent positive by moving through the fraction line. Make the exponent positive by moving through the fraction line. So the only thing that's going to stay up top is the 4. On bottom, we've got that 27. Usually you'll put the number out in front of the variables. But 27, the d is going to move to the bottom. Positive 16 now. The v is going to move to the bottom. Positive 8. And with the numbers, you've got 4 up top and then 27 on the bottom. If you had, for example, 4/28, you'd want to reduce that by, you could reduce it by 2 and then a little bit further by another 2, or you could notice that it reduces by 4 and just start from there. 4 and 27, though, they don't have anything in common, but you do want to check to see if you can reduce. So I'll put a question mark on that. Reduce. This one doesn't, so this is as far as we can go. Okay, we'll do one more of those. 3k to the third, v to the second, in parentheses, to the negative fifths, 4k to the seventh on bottom, v to the fifth. 3k to the third, v to the second, in parentheses, to the negative fifth. And then 4k to the seventh, v to the fifth. Nothing really new here. I just want to kind of go through the motions again. Everything in parentheses, the exponents, I'll put the 1 on the 3. Every one of those exponents, we're going to multiply by -5. I'd write that out, but that should be in your notes from level 2. So this is going to be 3 to what power? -5. 1 times -5 is -5. And then k to the -15, v to the -10. So that's all I'm going to do on this first step. Leave the bottom the same, 4k to the seventh, v to the fifth. And then just like the last one, we've got some k's. And if you've got k's on top and on bottom, subtract the exponents. V's on top and on bottom, subtract the exponents. And we'll do that subtraction up top. So I'll go ahead and leave this as 3 to the -5th, k to the -15 minus 7. V to the -10 minus 5. And it may not come up. I don't see it in any of the examples I wrote down, but if you did have a negative exponent on the bottom, remember you're subtracting that negative. So subtracting the negative exponent on bottom would be a plus. I don't think that's going to come up here, but just in case. And then on bottom, what's on bottom here? 4, that's it. The k to the seventh we dealt with, the v to the sixth, or v to the fifth we dealt with. So we've got 3 to the -5th, k to the -22nd, v to the -15th, and then all over 4. So like we did on the last one, if k's got a negative exponent, it's going to move through the fraction line. If b's got a negative exponent, it's going to move through the fraction line. What about the 3? Is it going to move? I think I heard a mix of answers there. If it's a negative exponent, it does have to move. So basically everything up top is going to move down below. So we've got 4, and all this stuff is multiplying. So when I bring that 3 down, it's going to be 3 to the 5th, k to the 22nd, and v to the 15th. And you guys remember what goes up top? 1. Yeah, if you move everything, you do have to put a 1 there. So on the next step, we've got 1 on top and 3 to the 5th. Let's see what that is. Okay, so 3 to the 5th turns into 243. So we've got 4 times 243. And then k to the, be careful the 3 to the 5th, you don't put 15. Sometimes people, they get to thinking they're multiplying there, but it's 3 times 3 times 3 times 3 times 3. It ends up with a pretty big number. And then that times 4. So 1. Okay, so pretty big number. Process is mostly the same though. Okay, next section, convert number to scientific notation. I just have two examples on this. So 0.0033, what you'll want to do is move that decimal after the first non-zero number. Move decimal after the first non-zero number. The first number that's not zero. And here, the first number that's not zero is that first 3. So we want to move the decimal from where it is 1, 2, 3 spots. So we're going to get 3.3, and we're going to multiply that by 10 to some power, and they'll give you a little box. So there's different ways you can look at this. I try not to give a hard rule because sometimes people confuse it when we convert to standard notation later. But basically, what you're doing is you're rewriting 0.0033. Is that a big number or a small number? It's a really, really small number. It's not even 1. It's not even close to 1. So it's really, really small. So the 3.3 times 10 to some power, that should really be the same thing. These should be equivalent. Is 3.3, is that bigger or smaller than 0.0033? It's bigger. So if we want this second, the 3.3 times 10, if we want that to be equivalent to the small thing, we need to take 3.3 times a really, really small number. So we did move that decimal 1, 2, 3 places. Here we want this to be -3. So 3.3, 10 to the -3 is a really, really small number. So we're taking 3.3 times something small to get something small. So these should be equivalent. Hopefully that makes sense. I would say if you move the decimal to the right, make it negative, but later on we're gonna, that could get confusing. But these should both be equivalent. Try to keep that in mind. So that's one example. 6,400,000. So I'm going to put a decimal after the first non-zero number. So the first non-zero number before was 3. The first non-zero number here is 6. So we're going to move the decimal right after it. And by the way, there's no visible decimal on the 6 million number, but you have to know that it's actually at the very, very end. And if you're going to move it 1, 2, 3, 4, 5, 6 spots. So this is going to be 6.4 times 10 to some power. And so what we've done is we've taken we want the 6.4 to somehow get back to this big number. So we've got to take 6.4 times something large to get back to that. So since we moved it 6 places, it's going to be +6. 6.4 times 10 to the 6, which is a big number, will give us 6.4 million. Convert scientific notation to standard form. So here we're doing the reverse. We're going to start with the scientific notation, which is some decimal number times 10 to some power. And we're going to go back to the number that starts with. So here we've got 5.5 times 10 to the 6th. .5 times 10 to the 6th. We're 10.6 or 10 to the 6th is a big number. It's 10 times 10 times 10, 6 times. So a really big number. So 5.5 should get very large when we multiply it. So we're going to move that decimal 6 places. You think to the right or to the left? Yep, to the right. We're going to make this really, really large number. So 1, 2, 3, 4, 5. Whoop, lost track. So it starts in the middle. 1, 2, 3, 4, 5, 6. And you're just going to fill those little gaps in with a 0. So 3 times 10 to the negative 4th. So 10 to the negative 4th is really, really small. So the decimal on the 3, it's right after the 3. It's not written explicitly, but we want to move it left this time. We want to make that 3 smaller than it is. So you got 3, and then we're moving that decimal from the right. 1, 2, 3, 4. Decimal there, and then 0, 0, 0, 3. So just to clean that up, 0.0003. Multiply, divide in scientific notation. A couple vocabulary words you'll want to know: quotient. That's another word for divide. Product. It's another word for multiply. So be careful, because they'll give you the same sort of structure of a problem, but on one, they might say they're looking for the quotient. On another one, they might say product. So just because it looks the same, be careful that you notice the difference. Let's see. What is the quotient of 1.892 times 10 to the 8th and 4.3 times 10 to the 3rd in scientific notation? What is the quotient of 1.892 times 10 to the 8th and 4.3 times 10 to the 3rd? So I want to highlight that it does say quotient. Quotient means division. So I'm going to write the 1.892 on top, the 4.3, and then the 10 to the 3rd on the bottom. So we're dividing. This is basically a fraction as a division problem. So 1.892 times 10 to the 8th divided by 4.3 times 10 to the 3rd. You might need your calculator for this one. One thing, when we had V's on top and V's on bottom, same base, you can subtract the exponents. Here we've got the same base of 10. So 10 to the 8th on top, 10 to the 3rd on bottom. We can just subtract those exponents. And that's basically how you divide those. And we can also divide these. Okay, so I'm gonna put that into the calculator. 1.892 1.892 divided by 4.3. What's the power of the 10 going to be? 8 minus 3 is 5. So we've got 0.44 times 10 to the 5th. Looks like scientific notation, almost scientific notation, except you want the decimal after the first non-zero number. First non-zero number is that 4. So this one, we're going to make 4.4 times 10. And we did move the decimal one spot. Yeah, -1. Because we took it from a larger number, or we took it from a smaller number to a larger number. If you want 4.4 to become smaller, you have to take it times a negative exponent. So now we've got 4.4 times 10 to the -1 times 10 to the 5th. And you might remember, just like up here, if we're dividing the same base, dividing tens, we can subtract the exponents. And down here, if we've got tens that we're multiplying, we can add those exponents. So 4.4, we're not doing anything with it, but -1 plus 5, +4. Okay, what is the product of 630 and 7.2 times 10 to the 4th in scientific notation? So I want to emphasize that this says product, not quotient. So on this one, we're multiplying. 630 and then the 7.2 times 10 to the 4th. I'm going to go ahead and multiply the 630 and the 7.2. And we get 4,536 times 10 to the 4th. (4,536 times 10 to the 4th, which is almost scientific notation, but you want the decimal to be after the first non-zero number. So after the 4, it starts after the 6. So in order to get it there, we've got to move it 1, 2, 3. So I'm going to make this 4.536. And since we moved it 3, we want the 4.536 to become larger to get to the 4,000. So we can take it times 10 to the 3rd. What's that? Right. Yeah, ultimately, that is what we're going to do. And then, so we've got 10 to the 3rd, we've got 10 to the 4th. We can add those exponents, 4.536 times 10 to the 7th. Okay, one more in this section. What is the product of 1.4 times 10 to the fifth and 2.7 times 10 to the fourth in scientific notation? Make sure you pay attention to whether it says product or quotient. If it was quotient, you put the one multiplication on top, the other multiplication on bottom, and then just divide the different things. But here we're multiplying them. I'm gonna go ahead and write this out. 1.4 times 10 to the fifth times 2.7 and 10 to the fourth. So just multiplying the two things that we're talking about. You could put them in parentheses. I'm gonna go ahead and pair up the decimals and then pair up the tens. Because when the tens we're multiplying everything. When the tens multiply, you'll add the exponents, and then 1.4 and 2.7, you can multiply that with the calculator. So 1.4 times 2 to the 0.7 times 10 to the fifth times 10 to the fourth. All I've done is just rearrange them a bit, putting the things that are more alike together. By the way, on the right, you should be able to do this in your head. 10 to the fifth times 10 to the fourth, 10 to the ninth, just adding those exponents. And then let's see, 1.4 times 2.7, 3.78. Okay, is this in scientific notation? Yep, the decimals after the first non-zero number.
Greater than 0 or less than 10.
Greater than 0 or less than 10. Okay, so that's the last one for that one. Let's see, Pythagorean Theorem. Yeah, I was just about to ask if anybody knew that. A squared plus B squared equals C squared. It only has to do with right triangles, but they're not going to try to trick you. Every single triangle they give you is going to be a right triangle in this.
Well, they'll use cubes and rectangles and then try to find a diagonal to get a right triangle.
No. Okay, so I'll give you a couple of these. In this section, at least. Okay, so I'll put the little box on the bottom left is an indication that it's a right triangle. So just in case it didn't look like it, like my second one doesn't really look like a right triangle, but the little box will tell you that it is. The thing that's most important here is determining what C is, which is pretty easy. It's always the longest side. Here we've got 8 and 6. On the other one, we've got 55 and 73. These are two separate problems, by the way. So I'm going to go ahead and zoom in on this one. Hypotenuse. Okay, so the longest side here, we're not given, it's C. On the 73, though, we're given C. And the 8 and the 6 on the left, we'll call those A and B. It doesn't really matter which is A or which is B, but the two shorter sides are A and B. The longest side you have to be very particular about. It has to be that 73 on the right one. Okay, so we've got A squared plus B squared equals C squared. just dealing with the first triangle, A is 8. So we want to replace A with 8. B is 6, so we're going to replace that. And then C, we don't know what C is, so we'll just leave it. So 8 squared plus 6 squared equals C squared. Anybody know 64 plus 36? 100? Right. Yeah, so we've got 100 equals C squared. Be careful you don't put an 100 in as the answer, because we don't want to know what C squared is equal to. We want to know what C is equal to. So I can't remember if this has come up at all, but if you've got a squared term like that C squared, and you just want the C, what you can do is you can square root it. And what you do is that cancels the square root and the 2. I think we may have had an example like that before. But if you square root the right, in order to get rid of the 2, you also have to do the same thing on the left. And then some of you might know the square root of 100 is 10. Yeah, it's actually 10 or negative 10, but negative 10 wouldn't make any sense for the length of C. So just 10 on that one. And then just doing the same thing on the second example, A squared plus B squared equals C squared. We can go ahead and let this unknown side be A. So A we don't know, we'll just leave it as A squared. But B is 55. And then C is 73. Make sure you square both of those, because it's B squared and then C squared. Put that in a calculator. 55 squared is 3,025. 73 squared, 5,329. We do want to know what A squared is, so we need to get A squared by itself in order to get rid of the 3,025. Right. So subtract it in order to get rid of that thing on the side with A squared in order to get A squared by itself. So A squared okay, so 2304. And then again, we ultimately want to know what A is. So we need to get rid of that squared part, square root it. So that gets rid of the 2. And then square root the right side also. So we end up with 28, 48. Okay. 48. And you should be able to do the square root of 2304 in your calculator. Anybody's unsure how to do that, I can come around and show everybody. Actually, before I do that, let me, in this part of the Deltamath and in the next part of the Deltamath, you're gonna be, I guess in this section, you just be looking for squares. These are perfect squares. So I'm just gonna make a list of them. You might keep that, after you take the notes, you might keep it maybe off to the side so you can kind of reference it when you're going through these. But perfect squares are just anything that you can make by squaring something. So I'll put sort of in thought balloons what's going on here. 1 squared, 2 squared, 3 squared. So that's the thinking that gets us the perfect square. So 1 squared, what's that? 1 times 1, 2 squared. 3 squared. 9. I'm not going to go super high with this list, but the next one would be 4 squared. 5 squared. 6. 7. I'm just going to go to 10 squared, so 100. And then we also have variable perfect squares. Those are pretty easy because they're just multiples of 2. If you were to say x to the first squared, x to the first times x to the first, you just add those ones, 1 plus 1, you get x to the second. So 2, 4, what's the next one going to be? 6, what's the next one going to be? 8, just multiples of 2, 2, 4, 6, 8, what's the next one? 10. Basically, if it's a variable exponent, if it's a multiple of 2, then it's a perfect square. So these are the numbers we're going to be looking for when we're simplifying radicals. Okay, so I'll do some examples off to the right. So we've got x squared, and then x to the 6th on the inside. X squared and x to the 6th. So let's see. The square root symbol, it has in that little nook, at the bottom where it kind of comes up a little bit, there is an invisible little number there. It's a 2. In some cases, it'll be a 3. But this tells us what we're looking for. We're going to look for squares inside. We're going to look for squares inside the radical. So these are the things that we're looking for, the perfect squares on the left. So if we look at the x to the 6th, we want to ask, is that a square? Does it have a square in it? X to the 6th is a square. If it wasn't, we might rewrite it so that we could see the square, but it is a square. So what we're going to do with variable exponents is we're just going to divide the 6 by the index, which is that 2 there. The index is 2. So in order to bring that x to the 6th out, we're just taking 6 divided by 2. So the x to the 2nd is still outside. And now when we bring that x to the 6th out, it's going to be x to the 3rd. And then, ultimately x to the 5th. So x to the 2nd, x to the 3rd, they're butted up against each other, multiplying. So we're just adding the exponents, 2 plus 3. Okay, so that's one example. Another example, square root of 16x. Square root of 16x. What's the index on this one? 2. Yeah, if it's invisible, there's a 2 in there, which means we're looking for squares inside. I know now all we've talked about is squares. When they have a 3 as the index, you look for cubes, and I'll explain what cubes are. Basically, cubes are just numbers that you make. Instead of 1 squared, you do 1 cubed, 2 cubed, 3 cubed. Make a list, and those are the numbers that you're looking for. Any squares inside there? Well, I heard 4. I think you have the right idea, but 16 is the square that's inside there, and when it comes out, it will be 4. So 16, is x a square? Yeah, x is too small. The smallest, this is x to the 1st. The smallest square is x to the second. It's not big enough to be a square. So it's gonna have to stay inside. But I'll go ahead and put a line through the 16. I heard some people say 4. The square root of 16 is 4. And then square root of x, right? X can't come out, but the square root of 16 can. Square root of 9x to the 7th. Nine is a square, so that's good. X to the 7th, is it a square? No, not a square, but x to the 6th is a factor of x to the 7th. So what we're gonna do is I'm just gonna rewrite this. 9 is already a square. X to the 7th can be x to the 6th times x to what power? Okay, x to the 6th times x to the 1st. Still same as x to the 7th, but now we've got a square that we can take out, and we've got a variable square that we can take out. Square root of 9, 3. And then with the variable x to the 6th, you're going to take the 6 and divide it by what? 2. Divide it by that. Divide by the index. So on the outside, it's going to be x to the 3rd. And then the rest of it had to stay inside. The x to the 1st, just square root of x. You could put x to the 1st, but always leave the 1 off. We don't write x to the 1st. We don't write 1x. Okay. Okay, we'll do one more section and then I'll let you guys work on it or work at wherever point you're at. Remember, on these notes, you are going to turn these in unless you're doing the NROC stuff. So make sure you're writing these down even if you are done with the section. Simplify algebraic square roots. Here we're basically doing the same thing. It's just a little bit more involved. First example, y, and then we've got 12, x to the 4th, y to the 7th. X to the 4th, y to the 7th. The index is 2 again. So we're going to be looking for squares inside. Hopefully you've got your list of squares that you can reference really quick. 12 is not on that list. But 12 does have a square in it. Four is a square in 12. 4 times what? 3, yeah. Still 12, but now we've written it to where we can see the square that's in it. So the square root of 4 is what's going to go on the outside. So that's going to be a 2 on the outside ultimately. X to the 4th, is that a square? Yeah, it's a multiple of 2. So I'm just going to leave it as x to the 4th. No need to rewrite it, but I am going to put a line through it and then bring it out. We're going to take that 4 divided by the index. Y to the 7th, not a square. What's the biggest square in y to the 7th? Y to the 6th times y to the 1. Okay, so I'm just going to put a line through the things that are coming out. The 4's, square root of 4 is going to come out. X to the 4th, it's a square, it's going to come out. Y to the 6th is a square, it's going to come out. So I'm just going to bunch everything on the outside. We've already got y. Square root of 4, 2. What's the square root of x to the 4th? X to the 2nd. Remember, you're taking that 4 divided by the index. I didn't write it here, but the index is 2. So 4 divided by 2 is going to be x to the 2nd on the outside. How many y's on the outside? 3 with the y to the 6th divided by 2, but we do have more y's outside that we will put together. And that's the only thing that we're taking out. What's left on the inside? Close. 3y. Okay, so then the only other thing, you know, I threw all that stuff outside, but the y's you might put together. This is y to the 1st. So y to the 1st and y to the 3rd, y to the 4th. And yeah, typically the 2 will go out front and then your variables in alphabetic order. Okay, we'll do one more of those. Nothing really new here. Basically, very similar to the last one. X to the 2nd, y to the 3rd, and then square root of 175, x to the 7th, y to the 7th. Index is 2. So we're looking for squares. Hopefully you've got your list. We just went to 100. If you're looking at your list, any of those pop out as factors of 175? 25. What would that be? 25 times 7? So the 25 we're going to take out, square root of 25 is going to be 5 on the outside. And then the x to the 7th, just like the last one we did, it's not a square, but we can write it as x to the 6th times x to the 1st. So x to the 6th will come out. Y to the 7th, the same thing. Y to the 6th times y to the 1st. So all the squares now are going to come out. 25, x to the 6th, y to the 6th, all those are going to come out. And then dividing the variable exponents by 2. So throwing the 5 out there, the x squared y to the 3rd, they're already out there. So the x to the 6th, when I bring it out, 6 divided by 2. X to the 3rd. The y to the 6th, 6 divided by 2. So that takes care of the 25, the x to the 6th, and then the y to the 6th, all the squares that were in there. Then on the inside, just have 7, x to the 1st, y to the 1st. How many x's do we have? How many y's? All right. Okay, so that's it for now. I'll post the rest of the notes in the PDF that you guys can see in Blackboard. I'll probably do that either later on today or tomorrow, so you can copy those notes down. But on Monday, should I finish this on Monday? Maybe I'll finish it on Monday. I'll send you guys an announcement to let you know. But we might finish it on Monday and then start the notes for Deltamath 5 on Tuesday. I'll think about it.
Well, isn't the notes due the 12th? That's Monday the 12th.
For module 4?
Yeah.
Okay, I'll post them later on today then.
we take a break?
Huh? If you want. Yeah, just 1 second. Let me kind of get. It's quiet today. Usually we don't have anybody absent in here. 4th of July. People were cut.
On vacation.
Is he?
Yeah. I don't know if that has anything to do with it.
Apparently it does. I mean,
Yeah, apparently.
Makes sense. The boss is away.
Yeah, hopefully if the boss is there. You should know that. Yeah, there you go. Get a little crazy and decide to play with a D8 or something. I'm still the only person I know that successfully kept themselves with sandpaper.
Hey, there always has to be one of them.
You know, I've watched videos where they take
I just module 4 test. I had to all the time trying to get the word as you wanted to. Every time I tried to put it in there, it would bunch up and you couldn't read it at all.
Yeah.
Because it looked like it would actually try and do it. So to make it easier on you, I also wrote the right points. I went ahead and showed my work in the little spot they had, so it probably took me longer to use it. I was writing it down and I was like, well, hopefully this gets you what you need, because like raise the second, or things like
Yeah,
that.
as long as you write it out and you submit your notes.
I did that too,
Okay, I
yes.
should be able to go from your paper because.
It's almost the exact same. I basically, the work I had, I put on the test was also what I did when I submitted the notes.
Okay.
But you can see on some of them, I could not get it to, see how it bunched all up together?
Right.
So I'm like, well,
Yeah,
how do you do
I got
that?
2 emails from people and I just decided I'm just gonna look at the
Well,
papers to decide.
When you look at it, you go into the notes there, it shows where you can do like insert.
Right,
It has like the omega symbol, and you can find mathematical insert,
right.
but it doesn't do the squares all the way. So you kind of had to like this. See how that's
Right.
technically a whole thing. But it only shows there, so hopefully I made it clear enough to still.
No, I'm sure. As long as you got it on the paper, that's real well, I'll have to go off.
And
Because obviously this is not the answer.
Yeah. You can see, to. Module 4 notes. It's basically the same thing, you can see it.
Yeah, that's probably what I'm gonna end up grading instead of.
Okay. I mean,
Because I got an email from Lyman and I got an email from it'll be easy for me to grade, I think. But from you guys, it looks like you submitted something.
yeah, I had to go a very roundabout way to do it because of the ability to put it on there.
Well, it won't be a problem going forward. This is the last module test. With rappers. But module 5 doesn't have 2 questions.
Speaking of, are you gonna open those up?
Oh, okay. Because I saw that a few of you are.
Yeah. Thank you.
Uh-huh. Pretty good. How you doing, Kristen?
Pretty good. I'll give you a chance if you could run through a cube one with me, because that's where I stopped at.
Okay.
50% done. But I'm gonna try to figure it
Well,
out.
let me get you started on it. And then I'll work on some good stuff after. It's basically just the same thing that we did before.
Right.
So let's make a list of cubes. So you do 1 cube, 2 cube, 3 cube. And you know how for the squares, variables in x to the second, 4, 6, 8.
This time it's gonna be like
3, 6. And you just look for those. And then, okay.
There you go. Just separate.
That's it. Yeah.
Like this, if you want to take that 6 and 2, right?
No. You're not looking for things that make. You're looking for, because by the way, 6 times 2 doesn't make. 4 times 2 does, but we don't care about either of those because we're only looking for cubes. Well, let's make a list of cubes. So remember how that's made. And then so on. Right. So let's make a list. It doesn't have to be super long, but 1 times 1 is 1. 3. No. Well, no, 1 to the third. What we're doing. That's a perfect. 2 times 2, 4 times 2. That's the hardest one in the last one. 4, I'd be surprised if you do that. Not surprised, but close. And then 5 times 5 times 5. That's probably the time we need. And then the variables. You already know that. Start with so this is all that we're looking for. Okay, that's all. So any cubes inside that you can see? Yeah, if you need to rewrite it. If it's already a cube, you can just leave it. Well, 8. So 8's going to come out. And by the way, you know when we did the cube root of 16 is 4 on the outside. Cube root of 8 is 2. Cube root of 27 is 2. Cube root of 125. Okay. So those would be the things that are on the outside. Okay. And then x to the 5th, how would you do that? X to the 5th. Exactly. And then so this is the cube. So it's going to come out. So I would recommend you rewrite the whole thing. And then when the x to the 3rd comes out, what's it going to be outside? Because because you're going to take this divided by the index, which is 3. Right. So 3 divided by 3 x to the 1st. Right. So you just go to your tallest one, right? You want to get most of that, which is x times x1, right? Yeah, y. And then y to the 9th, when it comes out, 9 divided by 3 and divided to the 3rd. And then you'll pair that up, ultimately to the y first and then y. Sir? No, you're good. You're good.
So look at this. So like this. Yes. So adding 4 is 3. Yes. So it would be 7, 8, to be 11, or
For the next 5 minutes. Good. Okay, so I got the 7 and 2 on the outside. They multiply to each other, right?
Well, they multiply by adding the exponent. Oh, you talking about the 7 and 2?
Yeah. So that's
Yeah,
just
let me just double check everything so far. So that looks good. This is a 5. That looks good. So 2 on the outside. X to the first. X squared divided. Yeah, and then how many x's are in that?
Oh yeah, you're gonna have 4.
4. Okay, you got it.
Yeah. Well, then.
Okay, Jeff, you should be able to get, I haven't opened the Module 5 folder yet, but if you can get into Deltamath, you should be able to get into the Deltamath 5.
Okay,
Got it? Okay. Hmm. Mm-hmm. Yeah. Well, you can deal with the x's. So remember how to do that? Yeah, we did a little bit of this today. Where you remember what you do with exponents? Subtract them. Maybe do that up top.
Okay.
Right. Yep, and then your 8 and 8 can reduce those. Yeah. So basically just cancel it out. Right. And then so for your final answer, you won't put the 1. You don't put 1. But you do have one more. I'll give you him. You gotta do something with this.
I'll make that positive.
Right. That's it.
So then, and I put 1 on top.
No, because everything is from the
So I made that one.
you moved this one below.
Wait, that's why I took on top.
Well, your list.
Cubes.
Well, no, not subtraction. Say just like if you had well, let's say, 24. So you have that. 8 goes into this. 24. So what you would do is you make this 8 times 3, and then that comes out. So you're looking for multiplication. Things will multiply. So one way you can check that is you could do 189 divided by these numbers. You could do 64 or 189 divided by 27. I don't think 64 is 27. Okay. So you might try to calculate that. Well, no, you gotta get some practice with this before.
So 9 and 27.
So you just do this with the 27.
27.
Right. Like that. And then the cube root of 27. Yeah, so this will come out.
Oh, I just reduced that.
Just reduce that.
Okay, so that'd be in the third.
1/3. Yeah.
Yeah.
Good job. Oh, it's a late due date. Okay. What did you do? You had it right. Not negative, because it'd be positive negative. I'm sorry. Right. Which you can extend on 5 to the third means 5 times 5 times 5. So what's 5 times 5 times 5? You said you got 3,000 something? Yeah. I don't know. You hear it right. Maybe if you know you get something and it doesn't show here like you might. How's it going? Have you already submitted that? Oh, okay. Well, my sentence. Okay. So you took out the 2. Okay, so the only thing here then is the rest is probably right. You probably want to see if there's any Q still in that 145. Because it's a big enough number that you could have. Yeah, you may have to read, just like you did here. It might be 8 times 20 or something. Okay, so interpret this out. But just you can just try these numbers if it's not one of those. I mean, you don't need to try one because one is 8. Just try those 4. And then what's the yeah, sometimes. And then you got one correct?
Yeah. Even though I couldn't know this. You're right. I got all my notes.
Yeah.
So -3.
No, nice. Just like here, you just reduce by.
Oh, I can't reduce that.
Yeah, you can.
Then I might force it back at times that. So that's, you know, so J to the 20.
Now, with these numbers, you do regular division, but with these,
You add,
you know, close.
you subtract.
Subtract. Yeah. And is that gonna be on top or bottom? The subtraction always takes place on the top.
Okay,
And if it's negative, then you move it. If the subtraction
the subtraction stays.
stays.
So my answer would be 3 over 4 J.
Right.
And if it was negative.
If it wasn't, if it was like 3 J, let's say you did the subtraction, you got that, over 4, you just need to move that
To the bottom.
to the bottom.
And then,
But in this case, it's just positive.
okay, when I move that to the bottom, I don't want it.
No, because the 3 stays, because the 3's exponent's already positive, so that doesn't need to do that.
Okay, thank you. Sir. Very well. I'm sorry.
What's that?
There was one that was thinking about.
Let me double check. I remember vaguely that we talked about that, but
It was just.
I can't remember if I put it in there. Mm-hmm. You got 100 on 1 and 2, so you must have gotten that. Bless you.